Derivation of the cosine rule. Naturally, we label the angles. If I call this A, this the opposite to A, this is capital A, the opposite will be little a. If I call this B, the opposite will be little b. And if I call that capital C, the opposite will be little c. Now I'm going to draw a height here. And this is now a right angle. If this side is, if I call that x, that distance from there to there, and if I call that x, and this side will be, because the whole thing is c, so this side will be c minus x. And this height here, we can call it height h. So we're going to use, we can say a right angle triangle. By the way, none of these angles are 90 degrees. So this is a NRAT, which means non-right angle triangle. That meant none of the angles are 90 degrees. But here it is 90 degrees, but it's not part of the angle in a triangle. So what we do is applying Pythagoras. So applying Pythagoras. Pythagoras says that h squared plus x squared will be equal to b squared. So I'm applying Pythagoras to this side here. And so now I can also apply the Pythagoras here as well, in this side 2 here. So for that side 1 and side 2, it will be h squared plus c minus x squared equals a squared. So now I want to eliminate the h, because I've got h squared here, I've got h squared here. So I can eliminate the h. So eliminate h squared, which means h squared will be equal to b squared minus x squared for that one. And here, h squared will be equal to a squared minus c minus x squared. So making h squared the subject, that implies that h squared equals b squared minus x squared. Likewise, making h squared the subject, that implies that h squared equals a squared minus c minus x all squared. So now both of them are equal to each other. So therefore, the right hand side here will be equal to each other. So b squared minus x squared, so if I put it here, b squared minus x squared will be equal to a squared minus c minus x squared minus c minus x all squared. So I need to expand c minus x all squared. If I'm expanding c minus x all squared, just remember the expansion to power 2. In this case, that would be b squared minus x squared equals a squared minus, so that would be, let me put a square bracket, so that would be c squared minus 2cx plus x squared. Okay, so if you're not sure what I've done in the expansion, I can explain that. If I have a plus b squared, the expansion will be in this case will be a squared 2ab plus b squared. So that's expansion for that, using binomial expansion. Obviously, there's a 1 here, 2 and 1. That's Pascal triangle numbers. And then you got the binomial expansion. Well, it's the same thing here. But A is C. So you just replace that with C. And B here is minus X. So the B here will be minus X. That makes that minus. And that's C. So we go minus 2CX. And minus x squared, minus will become plus if you square it. So that's why you get x squared. Right, so let's carry on with the expansion. So therefore, we get b squared minus x squared. So from that one here, equals a squared minus, because there's a minus here, you have to multiply everything by minus. So that's minus 1. Minus 1 times c squared is minus c squared. Minus 1, there's a 1 here. We don't write it because it's a default. Minus 1 times minus 2cx would be plus 2cx. Minus 1 times x squared will be minus x squared. And you can see the equal sign in between these two, left-hand side and right-hand side. If I add x squared to both sides, that would disappear. So we just get b squared equals a squared minus c squared plus 2cx. So let's make a the subject, a squared. Just make a squared. We could make b squared the subject. Actually, it doesn't matter. Let's make a squared the subject. So we'll leave a squared there and take everything on the right-hand side here except a squared to the left, which means the sign will change when you go to the left. So x squared will be equal to c squared plus b squared minus 2cx. Now we need to get rid of x. So we don't want x. We want to get rid of that. And that's actually nice because when we use a unit square, x is usually cosine angle. So let's get rid of x. So I'm going to find the angle here. This angle is actually capital A. That's why we label that A. That angle is capital C. That's why we label that C. And this angle is capital B. That's why we label that B. So to find the angle A, using the SOHCAHTOA, I'm using the car. So SOHCAHTOA is SOHCAHTOA. Sine equals opposite over hypotenuse. Cos equals adjacent over hypotenuse. Tangent equals opposite over adjacent. We are going to use these because I want to find the angle A. So for the angle A here, I'm going to say this is the adjacent here. That's the opposite. And this is the hypotenuse. So the cosine of angle A is going to be x from there to the adjacent over hypotenuse over B. B is the hypotenuse. And therefore, I would then have x to be equal to B, because I'm multiplying both sides by B, cos of A. So wherever I see the x, I can replace it with B, cosine of A. So now substitute x now into that equation. So I'm substituting x equals B cos A into the equation here. I could have numbered that equation. So that would be a squared equals c squared plus b squared minus 2. Well, because b comes before c alphabetically, so say 2bc cosine A. So what did I do there? I replaced that one here in that equation with this value here. And that's what I've done. So that derived what I needed to find. So the derivation then is a squared equals b squared plus c squared minus 2bc cos a. And for that reason, I could write it for the other ones as well. I could rearrange this and find cos a. So if I rearrange this, I need to take minus 2bc cos a to the other side, and then I'll get, and I'll take a to that side, so I get 2bc cos of a equals b squared plus c squared minus a squared. And I need to divide both sides by 2bc. So if I divide both sides by 2bc, I get cos of a will be equal to b squared plus c squared minus a squared over 2bc. Now you can see the pattern in writing this as well. bc minus a squared. b squared plus c squared minus a squared. And what am I looking for? I'm looking for cos a. Oh yeah, if I want to find the a actual angle, I have to divide again by cos, so which will give me cos to the power minus 1 here of that angle. And that's how I find of that value. And that's how I find a. So to find a will be 1 over cos, right? And then open bracket, b squared plus c squared minus a squared over 2bc. And that in indices is what you called cos inverse. And that's how you find a, the angle. So that will be b squared plus c squared minus a squared over 2bc. So this pattern repeats for the other ones as well. If I want to write b squared now, I could write b squared equals a squared plus c squared minus 2ac cos b. And if I were to write c squared, I could write c squared as well. C squared equals a squared plus b squared minus 2ab cos c. And if I want to, that's how the pattern works. And then you can rearrange them to find the angles as well. So for this one, the angle would be C will be equal to cos to the power minus 1, open bracket, right? Because you're moving that to the other side and then moving that to that side. So it will be a squared plus b squared minus c squared, close bracket, divided by 2ab. And if I want to find the angle for the b, it's same thing as well. So that would be b would be equal to cos to the power minus 1, open bracket, a squared plus c squared minus b squared divided by 2ac. That's how you derive the cosine rule function and rearrange it to suit your need.